Example 13, question 1. We need to find the vector equation of a plane containing two vectors. So this is my plane and I have vector m and vector n on this plane. Say that this is vector m and this is vector n. Note that here, this is just vectors, not position vector. If it says position vector, therefore, you can assume that it starts from the origin, and hence vector m will be from origin to coordinate m, and vector n will be from origin to vector n. But that's for position vector only. In this case, it is just vector. Therefore, you cannot put origin here. So you're just gonna leave it as vectors m and n. The vector equation of a plane is r dot n equal to a dot n, where n is the normal vector. So note that the normal vector is not the given vector n in the question. This is just a vector on the plane, not the normal vector. And we also need to find the vector a. So as we can see, the vector a will be either vector m or vector n. We also need to find the normal vector, which is actually the vector product of the two vectors given. Let's say I want to do the normal vector like this, which is the vector n cross with vector m. So let's try to find the normal vector first. And the normal vector is -3, 5, -2. And say that for vector a, I'm going to take the vector m as the vector a. So now, let's substitute both of these vectors into the vector equation of the plane. So copy down the vector r, substitute vector n, the vector a, which is the vector m, and the normal vector again. Simplify the right hand side and we will get 0. Note that for the vector equation, we need to write our answers in I, j, and k. So copy down r again, and this one right here can be written in I, j, and k. And that's the vector equation of this plane. Question 2, we need to find the Cartesian equation of a plane that passes through point 1, -1, 2. So say that this is the plane, and it passes the point 1, -1, 2. And this plane right here is parallel to another plane, which is 2x plus 4y minus 3z equal to 1. So actually for this question, we have two planes. So let's say this is plane 1 and this is plane 2. So we want to find the equation of plane 1. So this means that I need to find the vector a1 and vector n1 for plane 1. And we know that from the coordinate given in plane 1, we can find the a1, vector a1, which is 1, -1, 2. Next, I need to find the normal vector 1. So if this is the plane, therefore this will be the normal vector 1 for plane 1. Next, for plane 2, it's gonna have its own normal vector as well, which is n2. Now, let's recall from lines. Say that I have two lines, L1 and L2, and they are parallel to each other. So we know that L1 will have its own direction vector v1, L2 will have its own direction vector v2. Therefore, if these two lines are parallel, we can make the conclusion that v1 is equal to v2. So we're gonna apply the same concept to planes as well. Since the planes are parallel, therefore their normal vectors, which is n1 and n2, will become the same. And hence, n1 is actually equal to n2. So, I need to find n2 from the second plane. So, for plane, just note that the coefficient of x, y, and z will be the normal vector. So, the n2 is 2, 4, negative 3. And this is actually equal to n1. So now I can substitute n1 and a1 to find the equation of plane 1. The vector equation is r dot n equal to a dot n. Since this is plane 1, you're gonna write 1 for r and a. Next, we're gonna substitute n1 and a1. And if we simplify right hand side, we will get 2 minus 4 minus 6, which is negative 8. And for the left hand side, we need to write the vectors in I, j, and k. And this is the vector equation. However, we need to find the Cartesian equation. And to do that, you just need to let any of your r to become x, y, z. So if you have r1 or r2 or maybe r10, r is always x, y, z. So this equation, the vector equation, will become x, y, z dot 2, 4, negative 3, and it is equal to negative 8. And hence the Cartesian equation is actually 2x plus 4y minus 3z equal to negative 8.